So sabi ko nga kanina, ang goal talaga natin is to find all the zeros of a polynomial function of a degree n. Hindi pa tayo naghanap ng zero ha, nagpe-prepare pa lang tayo kanina. At ito, another preparation na naman. So sinasabi ng fundamental theorem of algebra that every non-constant polynomial with complex coefficients has at least one complex zero. Pero ito, feeling ko mas intuitive yung consequence niya. So if you have a polynomial p of degree n and a leading coefficient a sub n, then you can factor your polynomial as yung leading coefficient times x minus the root times x minus the roots, etc. up to the x minus the last root. And these r's are not, the roots are not, may not be distinct. So, pwede may magkakapareha. So, parang ang explanation dyan is that, so, kuwari, meron kang p of x. Diba ganyan itsura niyan? Polynomial siya, diba? A sub 1, x plus a sub naught. Pwede mo i-factor yung a sub n, magiging x sub n plus, tapos may coefficients kang bago. Okay, kapag finactor mo yung a sub n. And this is a polynomial. So sabi ng fundamental theorem of algebra, every non-constant polynomial with complex coefficients has at least one complex zero. So yung zero mo, let's say R1, ibig sabihin, by factor theorem, x minus R1 is a factor. Tapos may polynomial ka na naman dito. Tapos itong polynomial na to, ang degree niya is n minus 1. So pwede mo na naman i-apply yung fundamental theorem of algebra. So makakahugot ka na naman ng isa pang root, tapos may polynomial ka na naman. So hanggang sa mangyayari, mahuhugot mo lahat ng roots niya. R1 up to Rn. So, yan yung factoring ng mga polynomial. So, pwede mo express as a constant times x minus the root times x minus the root times x minus the root. So, sinulat ko lang ulit yung theorem sa previous slide natin. So, magbigay nga tayo ng example dyan. So, let's say p of x is x minus 1, 3 times x minus 1, x minus 1, x minus 1, x minus 1. Dami, no? Kasi meron akong gustong i-point out dito. Okay, suppose we have this polynomial. So, ang itsura niya, naka-ganyan siya. So, this is your a sub n. And your zeros are, so, equate mo lang actually each factor to 0. So, ilang 1, 4 na 1, isang 2, tsaka 2, 3. So, yan yung roots niya. So, binibilang pati yung pag-uulit. So, pupunta kasi tayo sa multiplicity. So, you can write this one as, di ba para ang natural na gawin mo, isulat siya as 3 times x minus 1 cube, x minus 1 square, x minus 1 to the, ilan ba x minus 1? 4. 1, 2, 3, 4. So, x minus 1 raised to 4, x minus 2 raised to 1, x minus 3 raised to 2. Diba? Parang mas natural na isulat mo siyang ganyan. Kapag nakaganyan ng form, nakikita nyo itong mga factors na iyan. So, si 1, kung ano yung exponent niya, yun yung multiplicity niya. So, we say that 1 is a 0 of multiplicity 4. Of multiplicity 4. So, susunod naman, 2 is a 0 of p of multiplicity 1. Of multiplicity 1. And then, yung huling-huli, 3 is a 0 of p of multiplicity 2. So, bale, parang ibig sabihin lang ng multiplicity kung ilang beses siya umuulit as a root or as a 0. And more technically, ito siya. So, yung polynomial mo, you can write it in this way where these r sub i's are distinct. At sabi natin, R1 is a zero of P with multiplicity M1. Kung ano yung exponent doon, siya yung multiplicity ng root sa loob. So, ang multiplicity ni R2 is M2, multiplicity ni RK is MK, etc. And ito yung ibang terms. And some remarks, makukuha mo yung degree ng P using the multiplicity. So, if you add all the multiplicity, you will get the degree of P. So, parang dito, anong degree nung P natin? Just add the multiplicity, which is 7. So, the degree of P is 4 plus 1 plus 2, which is 7. Okay, so next, if R is a root or a zero, palitan nga natin kasi zero ang gamit natin salita. So, if R is a zero of P with multiplicity 1, R is called a simple root. Kapag ang multiplicity mo ay 2, ang tawag doon ay double root. So, going back to this example, meron ba tayong single root at double root? 2 is a single root, 3 is a double root. So, gawa ulit tayo ng example. So, let's say we have a polynomial. Find a polynomial p of x of least degree having 2, 4 as simple roots and negative 1 as 0 of multiplicity 2 and p of 1 is 3. So, pag sabing roots 0, pareha lang yun. Isipin nyo pareha lang sila. So, you can write this one as, diba, constant x minus a root, x minus a root, tapos x minus, ano yung isang root? Minus negative 1. Pero ang multiplicity mo ay 2. Actually, yan na yung polynomial mo. Hahanapin mo na lang si A. Masulat nga natin na mas maganda. P of x is A times x minus 2, x minus 4, x plus 1 square. Ang gusto mo mangyari, P of 1 is 3. Kailangan mo na lang mahanap si A. So, P of 1, ano ba ang P of 1? A negative 1, 1 minus 4, 1 plus 1 square. Dapat daw equal yan sa 3. Saan equal itong bagay na to? 4, 3. So, 12A is 3. So, A is 1, 3 over 12 or A is 1/4. So, therefore, P of x ay 1/4 x minus 2, x minus 4, x plus 1 square. So, kung i-check nyo, ang roots niyan ay 2, 4 na simple at negative 1 na double root or multiplicity 2. And P of 1, makukuha nyo na 3. So, next example tayo. And another remark. So, if we have a polynomial na ang coefficients mo ay real and meron kang non-real na zero, ibig sabihin imaginary, then, yung conjugate ng root is also, yung conjugate ng zero is also a zero of P. So, example, kung 1 plus I ay root ng isang polynomial with real coefficient, yung 1 minus I, root niya rin. So, kumbaga, yung non-real roots come in complex imaginary pairs. A plus BI, A minus BI. So, mas madali siyang mag-gets kung meron tayong example. So, find a polynomial which has real coefficients and of least degree such that 1 minus 2i and 3 are its zeros and P of 0 is 30. So, kung ang zeros niya ay 3 plus 1 minus 2i and you want your polynomial to have real coefficients, sabi ng remark, kapag real coefficients, yung zeros mo come in complex conjugate pair Z, Z bar. So, ito yung Z mo, ang Z bar mo ay yung conjugate niya which is 1 minus o 1 plus 2i. And then, i-apply na natin yung parang ginawa natin sa previous example. Yung p of x mo is a constant, x minus the root, x minus 1 minus 2i, x minus 1 plus 2i. Multiply nga lang natin to ng kaunti, no? Para makita natin na real talaga siya. So, ito, you can write this one as x minus 1 plus 2i. Ito naman, x minus 1 minus 2i. Or, group natin yung x minus 1. Para lang mas madali mag-multiply. So, p of x, you can write it as a times x minus 3. Ito, difference of 2 squares. Oops, may mali akong nasulat. So, minus dapat ito. So, difference of 2 squares. So, you can write this as x minus 1 square minus the square of this, which is negative 4. So, magiging plus 4 siya. Hindi ba ano na ito? Real coefficients, may real coefficients. So, polynomial with real coefficients na to. So, let us find A. Sabi, P of 0 is 30. So, A times negative 3, 1 plus 4 is equal to 30. So, 30 is A times negative 15. So, A is negative 2. So, yung hinahanap nating polynomial is negative 2 times x minus 3 times this. At ito yung sinasabi ng isang theorem pa, kung ang degree mo ay n, yung number ng zeros mo ay n din. Kasama yung mga umuulit at saka yung mga hindi real. Yung mga a plus bi, a minus bi. So, gaya ng example na to, the degree of this polynomial is 3. And the roots are 3, 1 minus 2i, 1 plus 2i. Ano pa ba? Ang degree ng polynomial na to is 1 plus 1 plus 2 is 4. At ang roots niya ay 2, 4, negative 1, negative 1. And last example, itong polynomial, ang degree mo ay 7, ang roots mo ay 7. 1, 1, 1, 1, 2, 3, 3. Okay? And that ends our lecture on polynomials and their zero. End ng first part pa lang. So, meron pang second part. So, kita-kits ulit tayo sa susunod na video. Goodbye!